So yesterday we discussed questions related to direction ratios and direction cosines. Today we'll be discussing questions related to planes that are being asked in Civil Services examination and Indian Forest Service examination. So the question number says that equation of a plane containing line, this one, let me write it as L1. L1 is y by b plus z by c equals to 1 comma x equals to 0, and L2 is x by a minus z by c equals to 1 comma y equals to 0. So we are supposed to show that equation of plane containing line L1 and parallel to line L2 is this. So we have a direct formula for calculating equation of plane which is parallel to line 1 and is containing line 2. So for that we need to convert this equation of line into symmetrical form. So let us just do that first. So converting lines L1 and L2 in symmetric form. So that I'll get as y by b minus 1 equals to z minus z by c comma x equals to 0, and on further simplifying it I will get x minus 0 upon 0 equals to y minus b upon b equals to z upon minus c. Likewise I can do for equation 2 as well. So I will get x by a minus 1 equals to z by c comma y equals to 0. On further simplifying it I will get x minus a upon a equals to y minus 0 upon 0 equals to z minus 0 upon c. So the direct formula for finding a equation of plane passing through line L1 and parallel to line L2 is x minus x1, y minus y1, z minus z1, L1 m1 n1, L2 m2 n2 equals to 0. And from our equation we'll get x1 comma y1 comma z1 equals to 0 comma b comma 0, and L1 m1 n1 are 0 comma b comma minus c, and L2 m2 n2 are a comma 0 comma c. So if I substitute these values in this formula I will get x y minus b z 0 b minus c a 0 c equals to 0, which I can further simplify to get x into bc minus y minus b into ac plus z into minus ab equals to 0. On further simplifying it I will get bcx minus acy minus abz plus abc equals to 0. If I divide this whole equation by abc I will get x by a minus y by b minus z by c plus 1 equals to 0. And this is the exact equation of plane which we are supposed to prove in the question. Also, if you don't remember this formula, then we can do it by other method as well. We can just assume a general equation of plane passing through line L1. So any equation, let us do with that method as well. So any equation of line which is passing through L1 will be of form second method. So any equation of line passing through this L1 equation will be a into x minus 0 plus b into y minus b plus c into z equals to 0. And here my a, b, c are direction cosines of normal of plane. Now since my equation L1 is contained in this plane, so this equation L1 is perpendicular to normal of this plane which we have assumed. So using that relation I will get 0 into a plus small b into capital B minus small c into capital C equals to 0. Also my plane is parallel to this equation L2. So normal of my plane is perpendicular to this equation L2. So using that I will get the relation as small a into capital A plus 0 into capital B plus small c into capital C equals to 0. So I can just simplify this, solve this equation for A, B and C using cross multiplication. I will get by cross multiplication so I will get A upon BC equals to minus B upon AC equals to C upon minus AB. Let us equals to small k. Same. So from here I can calculate a value of ABC. So my A is KBC, B is minus ACK and C is minus ABK. If I substitute these value of A, B and C in equation of plane that I have assumed, let us name it as 3. So I will get KBC into X minus ACK into Y minus B minus ABK into Z equals to 0. If I further simplify it, I will get X by A minus Y by B minus Z by C plus 1 equals to 0. Using this method also we got the same equation as we got by our previous method. So now let us move to the part 2 of question. So in part 2 of question they have asked to show that 2D is shortest distance between the given lines. So if 2D is shortest distance between this line L1 and L2, then we are supposed to prove this relation. So if 2D is shortest distance between L1 and L2 and L1 is contained in the plane which we have just calculated, so 2D is also shortest distance. 2D is shortest distance between plane, let me name it as 4, and line L2. And we have a direct formula to find a shortest distance between a given plane and a given line. So that is, if my given plane is AX plus BY plus CZ plus D equals to 0 and equation of line is X minus X dash upon L equals to Y minus Y dash upon M equals to Z minus Z dash upon N, then shortest distance is, let me write it as SD equals to AX dash plus BY dash plus CZ dash plus D upon under root A square plus B square plus C square. So using this formula I will get 2D equals to, because 2D is my shortest distance between the two given lines or between plane and line L2, then I'll get my 2D equals to, so my line L2 is passing via point A 0 0. So my shortest distance is A upon A minus 0 upon B minus 0 upon C plus 1 divided by under root 1 by A square plus 1 by B square plus 1 by C square. So it is equals to 2D equals to 2 upon under root 1 by A square plus 1 by B square plus 1 by C square. So on simplifying it, I will get 1 by D square equals to 1 by A square plus 1 by B square plus 1 by C square. This is the exact relation which we are supposed to prove in the question. So we are done with this question. Let us move on to question number 2. So the question number 2 says that a variable plane which is at constant distance 3p from the origin cuts the axis at point A, B and C respectively. So let us assume, let variable plane be x by A plus y by B plus z by C equals to 1. So they have given shortest distance as 3p from origin. Then using the same formula which we have discussed in previous question, I can find a relation that is 3p is equals to 0 by a plus 0 by b plus 0 by c minus 1 upon under root 1 by a square plus 1 by b square plus 1 by c square. So if I simplify this equation, I will get 1 by a square plus 1 by b square plus 1 by c square equals to 1 by 9p square. Let me name this equation as star, as we'll be needing this equation later on. So the question further says that the variable plane cuts the x-axis, y-axis and z-axis at a, b, c respectively. So I can easily find out coordinates of a, b and c. So variable plane cuts x-axis at a. So if it cuts x-axis, then on x-axis my y coordinate and z coordinate will be 0. So from here, if I put y equals to 0 and z equals to 0 in equation number 1, I'll get x equals to a. So my a coordinate is small a comma 0 comma 0. Likewise, I can calculate my b coordinate. I'll get it as 0 comma b comma 0 and my c coordinate as 0 comma 0 comma small c. So in question further it says that we are supposed to show that locus of centroid of tetrahedron OABC is this. So let us assume a locus of centroid of tetrahedron, and here O is my origin. So if I let x comma y comma z be locus of centroid of tetrahedron OABC. So x comma y comma z is equals to x1 plus x2 plus x3 plus x4 by 4 comma y1 plus y2 plus y3 plus y4 by 4 comma z1 plus z2 plus z3 plus z4 by 4. And here xi's are x coordinates of these a, b, c and O point. Likewise yi's are y coordinates of these a, b, c and O point, and similarly for z. So since we have all the coordinates of a, b, c and O, we can easily calculate x, y, z, which is equals to a plus 0 plus 0 plus 0 by 4. Likewise we have 0 plus b plus 0 plus 0 by 4 and c as this one. On further simplifying it, we'll get x comma y comma z as a by 4, b by 4 comma c by 4. If I equate these, then I can easily get value of a. So my a is equals to 4x, b is equals to 4y and c is equals to 4z. So if I substitute, if I see that I have already calculated a relation in between a square, b square, c square and b. So if I substitute value of these a, b, c in equation star, I will get 1 by 4x square plus 1 by 4y square plus 1 by 4z square equals to 1 by 9p square. And on further simplifying it, I will get it as 9 into 1 by x square plus 1 by y square plus 1 by z square equals to 16 upon p square. And this is exactly what we are supposed to prove in question, I guess. Yeah. Now let us move on to question number 3. So the question number 3 says that find the equation of plane which passes through this point and is orthogonal to each of these planes. So first, orthogonal is same as being perpendicular. So let us assume a equation of plane which is passing through this point 2, 1, comma minus 1. So let a comma a into x minus 2 plus b into y minus 1 plus c into z plus 1 equals to 0 be equation of plane which is passing through 2, 1, minus 1 point. So in the question they have given us that equation of plane 1 is perpendicular to 1 is perpendicular to x minus y plus z equals to 1. Let us name it as 2. And also perpendicular to 3x plus 4y minus 2z equals to 0. Let us name it as 3. So if my equation of plane 1 is perpendicular to equation of plane 2, then my normal to plane 1 is also perpendicular to normal to plane 2. So using that relation, I will get a into 1 plus b into minus 1 plus c into 1 equals to 0, and a into 3 plus b into 4 plus c into minus 2 equals to 0. I got this because for two perpendicular lines L1 L2 plus M1 M2 plus N1 N2 equals to 0, where Li, Mi and Ni have usual meanings. So I can solve this equation in ABC using cross multiplication. So on solving this, we get a upon 2 minus 4 equals to minus b upon minus 2 minus 3 equals to c upon 4 plus 3. Let us say this is equals to k. So if I simplify this, I'll get a upon minus 2 equals to b upon 5 equals to c upon 7 equals to k. So from here I can calculate value of a, b and c. So my a is equals to minus 2k, b is equals to 5k and c is equals to 7k. So I can just substitute these values of a, b and c in equation number 1 to get the equation of required plane. So if I substitute these value in 1, I'll get, on substituting, I'll get minus 2k into x minus 2 plus 5k into y minus 1 plus 7k into z plus 1 equals to 0. And if I simplify this, I'll get minus 2x plus 4 plus 5y minus 5 plus 7z plus 7 equals to 0, which is equals to minus 2x plus 5y plus 7z plus 4 minus 5 minus 1 plus 7 plus 6 equals to 0. On further simplification, I will get 2x minus 5y minus 7z equals to 6. This is the required equation of plane. Now let us move on to next question. So the next question is, a variable plane is at constant distance 6 units from the origin and meets the axis in A, B and C. So find the locus of centroid of triangle ABC. So this question is quite similar to the one we have discussed previously. So let us assume a variable plane. Let x by capital A plus small y by capital B plus z upon capital C equals to 1 be variable plane. So here I have taken capital A, capital B, and let us take it something else, because A, B and C are already given as coordinates. Let x by P, y by Q plus z by R be a variable plane. So it is given that it is at a constant distance of 6 units from origin. Then using the distance formula, we can say that 6 is equals to 0 by P plus 0 by Q plus 0 by R minus 1 upon under root 1 by P square plus 1 by Q square plus 1 by R square. So if I simplify it, I'll get 36 into 1 by P square plus 1 by Q square plus 1 by R square equals to 1. Further it says that this equation of variable plane meets x-axis at a, b, c. So a, small a, 0, b, which is also equals to, from here also I can calculate where my plane will cut at x-axis. So I'll get A as p comma 0 comma 0 and B as, which is 0 comma b comma 0, as 0 comma q comma 0 and C as 0 comma 0 comma r. So from here A equals to p, b equals to q and c equals to r. So further it says that find the locus of centroid of triangle. So let x comma y comma z be centroid of triangle ABC. So therefore x comma y comma z is equals to summation xi upon 3 comma summation yi upon 3 comma summation zi upon 3. Here I is varying from 1 to 3. So if I substitute values of xi, yi, zi, I'll get x comma y comma z equals to p plus 0 by 3 comma 0 plus q plus 0 by 3 comma 0 plus r by 3. So if I simplify this, I'll get p equals to 3x, q equals to 3y and r equals to 3z. And earlier we have already found a relation of p, q and r. So if I just substitute value of p, q and r in the star equation, I'll get 36 into 1 by p square. So that is 1 by 3x square plus 1 by 3y square plus 1 by 3z square is equals to 1. On further simplifying it, I'll get 1 by x square plus 1 by y square plus 1 by z square equals to 1 by 4. And this is the required locus of centroid of triangle ABC. This is locus of centroid of triangle ABC. Now let us move on to question number 4th, I guess, or maybe 5th. So the question says that find the equation of plane containing the lines this and also find the intersection of given lines. So my L1 is x plus 1 upon 3 equals to y plus 3 upon 5 equals to z plus 5 upon 7. And my L2 is x minus 2 upon 1 equals to y minus 4 upon 3 equals to z minus 6 upon 5. So we have already seen a formula of equation of plane containing a line and parallel to line. If my equation of plane contain both these lines, then one of both the lines are parallel to the plane, so we can use that formula. So using that, equation of plane containing lines L1 and L2 is x plus 1 y plus 3 z plus 5 upon 3 5 7 1 3 5 equals to 0. I can just simplify it to find out equation of plane. Let us just simplify. X plus 1 into 25 minus 21 minus y plus 3 into 15 minus 7 plus z plus 5 into 9 minus 5 equals to 0. So if I simplify it, I'll get 4x plus 4 minus 8y minus 24 plus 4z plus 20 equals to 0. So on further simplifying it, I'll get 4x minus 8y plus 4z equals to 0. This is my required equation of plane which is passing through the given lines L1 and L2. And further in the question, they have asked us to find the point of intersection of given lines. So let us equate it with R1 and this one with R2. So we can easily find out any arbitrary point lying on equation L1 and L2. So any arbitrary point on L1, be A, let us just name it as A. So A will be 3R1 minus 1, 5R1 minus 3, 7R1 minus 5, and any point on L2B, let us name it as B. So my point B will be R2 plus 2, 3R2 plus 4, 5R2 plus 6. So we are able to find these points by individually equating these terms with R1. Like first I equated this one with R1, then I got X. Likewise for this and this. So if these two lines are intersecting, then there will be at least a common point in between. And since we have assumed A and B to be arbitrary point on line L1 and L2, so there must exist some value of R1 and R2 where these 2 points are equal. So let us just equate these 2 points A and B. So on equating A and B, we get, so from here we'll get three relations of R1 and R2, and we can just find out value of R1 and R2 by solving those. So on equating, I'll get 3R1 minus 1 equals to R2 plus 2, 5R1 minus 3 equals to 3R2 plus 4, and 7R1 minus 5 equals to 5R2 plus 6. So if I simplify this, I'll get 3R1 minus R2 equals to 3, 5R1 minus 3R2 equals to 7, and last one is 7R1 minus 5R2 equals to 11. So let me solve these two equations first and see what I got value of R1 and R2. So if I just multiply this equation by 3, I'll get 9R1 minus 3R2 equals to 9, and 5R1 minus 3R2 equals to 7. So if I just subtract it, I'll get 4R1 equals to 2. So from here I got my R1 as 1 by 2. Now substituting this value of R1 here in this equation, I will get 3 into 1 by 2 minus R2 equals to 3. So from here I got my R2 as 3 by 2 minus 3, which is equals to minus 3 by 2. So my R1 is 1 by 2, my R2 is minus 3 by 2. Now I'll substitute these value of R1 and R2 in this equation, and we'll see if this satisfies the equation, because only then we'll get an intersecting point. So 7 into 1 by 2 minus 5 into minus 3 by 2 is equals to 7 by 2 plus 5 3 is 15 by 2, which is equals to 22 by 2, which is equals to 11. So since these value of R1 and R2 satisfies this third equation as well, so I got value of R1 and R2 where these two equations intersect. So my intersecting point is 3R1 minus 1, 3 by 2 minus 1, 5R1 minus 3, 5R1, 5 into 1 by 2 minus 3, and 7R1 minus 5, I guess. 5R1 minus 3, 7R1 minus 5, which is equals to 1 by 2 minus 1 by 2 minus 3 by 2. So this is the intersecting point of line 1 and line 2. That's all they've asked in this question, Let us move to next question. So in next question they have asked to find the equation of plane passing through this point and perpendicular to this plane. So let us assume an arbitrary plane passing through this point. Let A x minus 1 plus B y minus 1 plus C z minus 1 equals to 0 be any arbitrary plane passing through this point. So on simplifying it, I'll get A x minus 1 plus B y plus 1 plus C z minus 1 equals to 0. Since this plane passes through this equation as well, this point as well, so this point must satisfy this equation. So substituting a value of x equals to minus 2, y equals to 1 and z equals to minus 1, I'll get A into minus 3 plus B into 2 plus C into minus 2 equals to 0, which is minus 3A plus 2B minus 2C equals to 0. Also in the question they have given us that the plane which is passing through these points is perpendicular to this. So if this plane 1 is perpendicular to the plane given in question, then their normals are also perpendicular. So using that I got 2A plus B plus C equals to 0. I can solve these two equations for A, B and C using cross multiplication method. So solving these via cross multiplication, we got A as 2 minus 2 equals to minus B upon minus 3 plus 4 equals to C upon minus 3 minus 4. On simplifying, I will get A upon 4 equals to B upon minus 1 equals to C upon minus 7. Let us equate it with K. So from here I can get value of ABC in terms of K. So I'll get A as 4K, B as minus K, C as minus 7K. So let us just substitute these value of ABC in equation number 1. So we'll get 4K into x minus 1 minus K into y plus 1 minus 7K into z minus 1 equals to 0. So if we just simplify this equation, we'll get 4 into x minus 1 minus y plus 1 minus 7 into z minus 1. On further simplifying, we'll get 4x minus y minus 7z minus 4 minus 1 plus 7 equals to 0, which is equivalent to 4x minus y minus 7z plus 2 equals to 0. So this is the required equation of plane that we are supposed to find in this question. So let us now move to next question. So the next question is, a point P moves on the plane this which is fixed. So we have a point P. Let P be alpha, beta and gamma be the point P, and this point P moves on this plane. So P moves on x by A plus y by B plus z by C equals to 1. Let us name this plane as equation 1. So if my point P moves on equation number 1, then I'll get alpha upon A plus beta upon B plus gamma upon C equals to 1. Let us name this as equation number 2. Further question says that the plane through P, so the plane passing through P is perpendicular to OP. So the plane which is passing through P is perpendicular to OP. So equation of plane passing through P and perpendicular to OP will be, so first let's see what the direction ratios of OP will be. Alpha minus 0, beta minus 0, gamma minus 0. And plane via P and perpendicular to OP will be alpha into x minus alpha plus beta into y minus beta plus gamma into z minus gamma equals to 0. And if I simplify this, I'll get alpha x plus beta y plus gamma z equals to alpha square plus beta square plus gamma square. Let us name this as equation number 3. Now in the question, they further says that the plane through P and perpendicular to OP meets the axis in ABC. So this plane 3, which is perpendicular to OP and passing via P, meets axis at ABC. So we can just calculate value coordinates of A, B and C. So at A this meets at x-axis, so their y and z will be 0. So we'll get A as alpha square plus beta square plus gamma square upon alpha, 0, 0. Likewise, we'll get B as 0, alpha square plus beta square plus gamma square upon beta, 0. And my point C as 0, 0, alpha square plus beta square plus gamma square upon gamma. So they further says that the plane through ABC parallel to YZ, ZX and XY planes respectively. So the equation of plane via point A is parallel to YZ. That is, equation of plane via A is parallel to YZ plane. So if this is parallel to YZ plane, parallel or perpendicular? Yeah, it is parallel to YZ plane. Then equation of this plane will be perpendicular to x-axis. Yeah, so equation of plane via A will be perpendicular to x-axis, because if I assume, let's say this is my equation, so x, this is my y axis and this is my z axis. So if any equation of plane which is perpendicular to parallel to YZ plane, then it will be something like this. So x-axis will be passing through it like this. So this equation of plane will be perpendicular to x-axis. So using that I can find equation of plane passing via A. So equation of such plane will be x equals to alpha square plus beta square plus gamma square upon alpha, because my direction cosine of x-axis are 1, 0, 0. So from here I got my equation of plane via A as this. Similarly, I can calculate equation of plane via point B, which is parallel to XZ plane. So I got my equation of plane as y equals to alpha square plus beta square plus gamma square upon beta, and similarly I'll get z equals to alpha square plus beta square plus gamma square upon gamma. This is equation of plane passing via C and parallel to XY plane. So further this is that these three planes, let us name them something. Let me use different color. These three planes, let's say star 1, star 2, star 3, intersect at point Q. So they say that star 1, star 2, star 3 intersect at Q. So I can easily calculate value of Q coordinate. So Q x y z will be equals to alpha square plus beta square plus gamma square upon alpha, alpha square plus beta square plus gamma square upon beta, alpha square plus beta square plus gamma square upon gamma. So this is my Q point where these three planes intersect. So they have asked us to prove that locus of Q is, so we are supposed to calculate locus of Q. locus of q is, we have to show that it is x square 1 upon x square plus 1 by y square plus 1 by z square equals to 1 by ax plus 1 by by plus 1 by cz. 1 by ax plus 1 by by plus 1 by cz. So I can just substitute value of these x, y, z here and then we'll check if they are coming out to be equal. So let us just calculate left hand side, which is 1 by x square plus 1 by y square plus 1 by z square, which is equals to alpha square upon alpha square plus beta square plus gamma square whole square. Likewise 1 by b square 1 by y square will be plus gamma square whole square plus gamma square upon alpha square plus beta square plus gamma square whole square. On simplifying it, I'll get left hand side as alpha square plus beta square plus gamma square. Now let us just calculate right hand side as well, which is equals to 1 by ax plus 1 by by 1 plus 1 by cz. So I got my, let's just put value of x, y, z. 1 by a into my x is, okay, alpha upon alpha square plus beta square plus gamma square plus 1 by b into beta upon alpha square plus beta square plus gamma square plus 1 by c into gamma upon alpha square plus beta square plus gamma square. So I can just take out 1 upon alpha square plus beta square plus gamma square as common. So I'll left with alpha upon a plus beta upon b plus gamma upon c. Now I'm just supposed to eliminate this term from here. So if I see that I have this term equals to 1 because point P passes through the given plane. So if I just put this value equals to 1, I'll get my right hand side as well equals to 1 by alpha square plus beta square plus gamma square. So my LHS equals to RHS. So the locus of point Q is this only. So we have verified that that is the locus of the point Q. So let us move on to next question. So in next question they have asked to find the equation of plane which is parallel to this. So equation of plane parallel to 3x minus y plus 3z equals to 8 is 3x minus y plus 3z plus t equals to 0. Let mine 8 equals to 0, and it is passing via point this. So 1 is passing via 1 comma 1 comma 0. So from here I'll get 3 into 1 minus 1 plus 3 into 1 plus t equals to 0. So I got my equation as 3 minus 1 plus 3 plus t equals to 0. So from here I got my d as minus 5. So equation of required plane is, so required plane is 3x minus y plus 3z minus 5 equals to 0. This is the required equation of plane. This is a really simple question and they have asked it for 12 marks. So let us move on to next question. So in next question they have asked to show that angle between the planes given by this equation is this. So we have a direct formula for calculating angle between the planes. So the formula is, if equation of plane is ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy equals to 0, then tan theta equals to 2 under root f square plus g square plus h square minus ab minus bc minus ca divided by a plus b plus c. So first let us just compare the given equation and calculate value of a, b, c and f, g, h. So on comparing, I got my a equals to 2, b equals to minus 1, c equals to 3, yz 2f equals to 2, so f equals to 1, and 2g equals to 7, so g equals to 7 by 2, and 2h equals to minus 1, so h equals to minus 1 by 2. So let us just substitute these values of a, b, c and f, g, h in the given formula. So tan theta equals to 2 under root f square, which is 1 square, plus g square 7 by 2 square, plus h square, which is minus 1 by 2 square, minus ab, so a into b is minus 2, minus bc is minus 3, and minus ca is 6, divided by a plus b plus c, that is 2 plus minus 1 plus 3, which is equals to tan theta equals to 2 under root 1 plus 49 by 4 plus 1 by 4 plus 2 plus 3 minus 6, so upon 3 plus 2 5 minus 1 4, which is equivalent to 2 under root 50 by 4 upon 4. This 3 plus 2 plus 1 6, this balances out as minus 6. So we got my tan theta as under root 50 upon 4. So my theta as tan inverse under root 50 upon 4. Yeah, this is the angle between these. If you don't remember this formula in exam, so what you can do is you can just assume two planes. So let me show that as well. So the given equation of plane is 2x square minus y square plus 3z square minus xy plus 7zx minus xy plus 7zx plus 2yz plus 2yz equals to 0. So let us assume two equation of plane a1x plus b1y plus z1 equals to 0 and a2x plus b2y plus 3z2 equals to 0. So what you can do is we can take coefficient of y as well. Let's just take it as b1. So what you can do is just multiply these two equations and just compare coefficients of x square, y square, z square and xy, yz and zx likewise. So from that you can get some estimate regarding value of a1, b1, a2, b2, and then you can just use formula of calculating angle between two lines, because angle between these two planes will be same as angle between normal of the perpendicular to these two lines, so that you can easily calculate using that cos theta wala formula. So let us just move on to next question. So the next question says that find the equation of plane parallel to this one and at a distance 2 from it. So equation of plane parallel to 3x minus 2y plus 6z plus 8 equals to 0 is, it will be of form 3x minus 2y plus 6z plus d equals to 0. So it further says that distance between equation of plane 1 and equation of plane 2 is 2. So that is equals to 2 equals to d minus 8 upon under root 3 square plus minus 2 square plus 6 square. because equation of plane, distance between two parallel planes, let planes are ax plus by plus cz plus d1 equals to 0 and ax plus by plus cz plus d2 equals to 0 is, so distance is d1 minus d2 modulus upon under root a square plus b square plus c square. So using this formula I got this equation. So if I simplify it, I'll get 2 equals to mod d minus 8 upon under root 9 plus 4 plus 36. So I got it as 14 equals to mod d minus 8. So if I simplify it, I'll get d minus 8 equals to plus minus 14. So from here I got two values of d, that is 8 plus minus 14. So d is either equals to 22 or d is equals to minus 6. Yeah, so the equation of plane parallel to given, there are two planes which are parallel to this given plane at distance 2, is 3x minus 2y plus 6z minus 6 equals to 0 and 3x minus 2y plus 6z plus 22 equals to 0. We can also see that if like this is my equation of plane, then there can exist a plane on this side as well which is 2 units away from this plane, and there can exist a plane on this side as well which is 2 units away from the given plane. So from there also we can say that we'll have two planes which are parallel to this and 2 units away from this plane. So these are the two planes which are parallel to given plane. So let us move on to next question. So in next question they have asked to find a equation of plane passing through point this and parallel to x-axis. So equation of plane via this point, equation of plane via 2, 3, 1b a into x minus 2 plus b into y minus 3 plus c into z minus 1 equals to 0, where a, b, c are direction cosines of normal to the plane which is passing through point 2, 3 and minus 1. Let us name it as equation number 1. So the equation 1 is also passing through this point 4, minus 5, 3. So this point must satisfy the equation of this plane. So we'll get, using that we'll get a into 4 minus 2 plus b into minus 5 minus 3 plus c into 3 minus 1 equals to 0. If I simplify it, I'll get 2a minus 8b plus 2c equals to 0. Let us name it as equation number 2. It further says that this equation of plane which is passing through these 2 points is parallel to z x-axis. Yeah, it's x-axis. So if it is parallel to x-axis, then normal to this plane will be perpendicular to x-axis, and we know that direction cosines of x-axis are 1, 0, 0. So the normal to this plane 1 will be perpendicular to x-axis. So using that I'll get a into 1 plus b into 0 plus c into 0 equals to 0. So from here I got my a as 0. So I can just substitute this value of a into to find b and c. So I got minus 8b plus 2c equals to 0. So if I simplify it, I'll get 4b equals to c and b by 1 equals to c by 4. Let us equate with k. So I got b equals to k and c equals to 4k. So we can just substitute values of this a, b, c in equation number 1. So if we do that, we'll get a is 2. So a is 0. So 0 into x minus 2 plus k into y minus 3 plus 4k into z minus 1 equals to 0. So if we just simplify this, we'll get y minus 3 plus 4z minus 4 equals to 0. So we get y plus 4z minus 7 equals to 0. So this is the required equation of plane which is passing through these 2 points and parallel to x-axis. Let us move on to next question. So in next question they asked us to find the equation of plane containing the straight line this and parallel to straight line this. So we have a direct formula for calculating a equation of plane which is passing through a particular line and parallel to another line. We have seen that formula in previous questions as well. So that formula is x minus x1, y minus y1, z minus z1, L1 m1 n1, L2 m2 n2 equals to 0. So if we just I guess first I need to convert the given equation in symmetric form, then only I'll be able to substitute value in this formula. So first let's convert given equations into symmetric form. So the equation of line 1 is y plus z equals to 1 comma x equals to 0. So I can write it as y minus 1 equals to z comma x equals to 0. It is same as saying x minus 0 upon 0 equals to y minus 1 upon 1 equals to z upon 1. And another equation is x minus z equals to 1 comma y equals to 0. So if we simplify it, I'll get x minus 1 equals to z comma y equals to 0. On further simplifying, I'll get x minus 1 upon 1 equals to y minus 0 upon 0 equals to z minus 0 upon 1. So I'll just substitute these value in the above formula. So we'll get x, since the equation of plane is containing this line. So be mindful of which line the plane is containing because that will change the plane. So equation of plane is x y minus 1 z 0 1 1 1 0 1 equals to 0. So we can just simplify this to find equation of plane. So if we simplify this we'll get 1 minus 0 minus y minus 1 0 minus 1 plus z into 0 minus 1 equals to 0. On further simplifying we'll get x plus y minus 1 minus z equals to 0. So the equation of plane is x plus y minus z equals to 1. So this is the required equation of plane which is passing through this line and parallel to this line. So let us move on to next question. So the next question says that find the equation of plane which passes through this and this. So let plane passing via 0 1 comma 1 be a into x minus 0 plus b into y minus 1 plus c into z minus 1 equals to 0. And here a, b, c are direction cosines of normal to the plane which is passing through 0 1 1. So this plane, let us name it as equation 1. So this plane is also passing via 2 0 minus 1. So 2 0 minus 1 should satisfy this equation 1. So by that we'll get also passing via 2 0 minus 1. So we'll get a into 2 plus b into minus 1 plus c into minus 2 equals to 0, which is equals to 2a minus b minus 2c equals to 0. Let us name it as equation 2. So it further says that the equation of plane which is passing through these 2 points is parallel to line joining these. So if this equation of plane in 1 is parallel to these lines, then normal to this plane will be perpendicular to this line. So we just need to calculate the direction cosines of this line passing through these 2 points, and then we can just use the perpendicular formula to get another relation in ABC. So direction cosines of line passing via -1, 1, -2 and 3, -2, 4 is 3 minus -1, comma -2 -1, 4 minus -2. That is 4 minus 3, 6. So this plane is parallel to the line with this direction cosine. So the normal is perpendicular to line with this direction cosine. So we'll get 4a minus 3b plus 6c equals to 0. This is equation number 3. So using cross multiplication we can solve equation number 2 and 3 to get values of a, b, c. So if we do that, we'll get a as -6 minus 6 equals to minus b upon 2 into 6, 12 plus 4 to the 8 equals to c upon -6 plus 4. So in simplifying, I'll get a upon -12 equals to b upon -20 equals to c upon -2. Let me just cross check it. I guess there's something wrong. 2a minus b minus 2c equals to 0. So a upon -6 minus b upon 12 plus 8 c upon -6 plus 4. No, everything is correct. So if I equate with it with k, so I get value of a as we can just equate it with k. So we'll get a equals to -12k, b equals to -20k and c equals to -2k. So we can just substitute value of a, b, c in equation number 1 to get the plane which is required. So that is -12k into x minus 20k into y minus 1 minus 2k into z minus 1 equals to 0. So if I just simplify it, I'll get -12x minus 20y plus 20 minus 2z plus 2 equals to 0, which is equals to -12x minus 20y minus 2z plus 22 equals to 0, and I can just divide by 2. So I'll get -6x minus 10y minus z plus 11 equals to 0. So this is the required equation of plane. And they have asked something as well. So further they have asked is what is the distance between line and the plane. Okay, so let us name this as equation number 4. So we have earlier calculated direction cosines of the line which is passing through given points. So we can just calculate equation of line as well. So equation of line via -1, 1, -2 and dc's as 4 minus 3, 6 is x plus 1 upon 4 equals to y minus 1 upon -3 equals to z plus 2 upon 6. So further they have asked what is the distance between line and the plane. So we have a formula to calculate distance. So distance equals to modulus -6 into -1 minus 10 into 1 minus of -2 plus 11 divided by under root -6 square plus -10 square plus -1 square. We have a formula which is distance equals to ax1 plus by1 plus cz1 plus d upon under root a square plus b square plus c square if our line is passing through x1, y1, z1 point. So if we just simplify, we'll get distance as modulus of 6 minus 10 plus 2 plus 11 divided by 36 plus 100 plus 1, which is equals to 1. 6 plus 2 8 minus 2 plus 9 upon under root 137. So 9 upon under root 137 units is distance between the plane and the line. So let us move on to next question. So this question is again similar to the one which we have discussed. So we are supposed to prove that locus of centroid of tetrahedron OABC is this one. So let us see what the question says. A variable plane is at constant distance p from origin. So let us assume a variable plane as x by a plus y by b plus z by c equals to 1. Let us name it as equation 1. So this is at distance p from origin. So using distance formula we'll get p equals to 0 by a plus 0 by b plus 0 by c minus 1 upon under root 1 by a square plus 1 by b square plus 1 by c square. So if I simplify it, I'll get 1 by a square plus 1 by b square plus 1 by c square equals to 1 by p square. It further says that this equation of variable plane meets the axis at a, b, c. So we can calculate coordinates of a as a, 0, c, 0, b as 0, b as 0, and c as 0, 0, c. So we are supposed to prove the locus of centroid of tetrahedron. And O is base origin only. So let x, y, z be locus of centroid of tetrahedron OABC. So we'll get x, y, z as a by 4, b by 4, c by 4. So if we equate, we'll get a equals to 4x, b equals to 4y, and c equals to 4z. So if I just substitute these values of a, b, c in this relation, so we'll get 1 by 4x square plus 1 by 4y square plus 1 by 4z square equals to 1 by p square. So if I simplify it, I'll get 1 by x square plus 1 by y square plus 1 by z square equals to 16 by p square. I think this is what we are supposed to prove. Yeah. So these kind of questions often get repeated. So if you get the gist of it, then it's a very easy task. So the next question is, if a plane cuts axis in ABC and ABC are coordinates of centroid of triangle ABC, then show that equation of plane is this. Okay, this one is also similar to the previous question which we have discussed now. If a plane cuts axis in A, B, let us assume an equation of plane. Let x by p plus y by q plus z by r equals to 1 be equation of plane. We are taking p, q, r because in question they have already used a, b and c. So just to differentiate, we are using p, q, r. So this plane cuts axis in a, b and c. So I'll get value of a as p, 0, 0, coordinate b as 0, 0, q, and c as 0, 0, r. I am taking these questions really fast because these are on the repeated topic and we have discussed these similar questions earlier as well. So I got my a, b, c as 0, and a, b, c are the coordinates of centroid of triangle. So a, b, c is centroid of triangle ABC. So since I have coordinates of a, b and c point, then I can calculate centroid of triangle ABC. So I'll get a, b, c as p plus 0 by 3, 0 plus q plus 0 by 3, 0 plus 0 plus r by 3. So if I equate, I'll get a, b, c as p by 3, q by 3, r by 3. So from here I can calculate value of p equals to 3a, q equals to 3b, and r equals to 3c. So I can substitute these values of p, q and r in the equation of plane that we have assumed initially. So the equation of plane will become x upon 3a plus y upon 3b plus z upon 3c equals to 1. So if I simplify it, I'll get x upon a plus y upon b plus z upon c equals to 3. And I guess this is what we are supposed to prove. Yeah, we are supposed to show that equation of plane is this. So this is also a simple question. So let us move on to next. Discuss the last question. It says that this plane is rotated through right angle about the line of intersection with this plane. So plane 1 is, let's say it is P1, x minus 2y plus 3z equals to 0, and plane 2 is P2, 2x plus 3y minus 4z minus 5 equals to 0. So plane 1 is rotated through line of intersection of P1 and P2. So line of intersection of P1 and P2 plane will be x minus 2y plus 3z plus k into 2x plus 3y minus 4z minus 5 equals to 0. So if you observe carefully that the equation of plane in new position will also pass through this line of intersection, because this plane 1 is using it as axis to rotate. So line of equation of new plane will also pass through this. Let's say this is 3. Also that equation in plane P1, let's say this is my plane P1, is rotated by 90 degree to reach this plane. And this is, let's say, my plane. This is P1, this is P2, and this is line of intersection. So this is rotated by 90 degree to reach position P3. So if you observe that P3 also contains this line of intersection of plane P1 and P2. Also plane P1 and P3 are at 90 degree. So direction ratio, so normal to plane P1 will be perpendicular to normal to plane P2. So we'll use this relation that normal to these two planes will be perpendicular to each other to find value of k. First let us just simplify this equation. 3 will get 1 plus 2k into x plus minus 2 plus 3k into y plus 3 minus 4k into z minus 5k equals to 0. So this must be perpendicular to 1, so their normals are also perpendicular. So using that I'll get 1 into 1 plus 2k minus 2 into minus 2 plus 3k plus 3 into 3 minus 4k equals to 0. So if I simplify it, I'll get 1 plus 2k plus 4 minus 6k plus 9 minus 12k equals to 0, which is equivalent to saying that 2k plus minus 6 minus 18 minus 16k plus 4 plus 9 13 plus 1 14 equals to 0. So from here I got my k as 7 by 8. So if I just substitute this value of k in equation 3, I'll get new position of plane P1. So just putting value of this k in equation 3, I'll get x minus 2y plus 3z plus 7 by 8 into 2x plus 3y minus 4z minus 5 equals to 0. So this is new equation of plane. You can either leave it here or you can just simplify it. So on simplifying we'll get 1 plus 14 by 8x plus minus 2 plus 21 by 8 y plus 3 minus 7 by 2 z minus 35 by 8 equals to 0. Let's just keep it in 8 form. 7 4s are 28, because that will help us eliminate later. 3 minus 7 4s are 28 by 8. Yeah. So on simplifying, we'll get 14 plus 8, 22 by 8x plus 21 minus 16, 5 by 8y plus 24 minus 28 minus 4 by 8z minus 35 by 8 equals to 0. So on further simplifying, we'll get 22x plus 5y minus 4z minus 35 equals to 0. So this is equation of plane in new position. So this is the last question for today. So if you have observed that questions are asked on similar lines, so even if you prepare previous year questions well, then also you can do good in examination. So thank you for today. Tomorrow we'll discuss questions related to straight lines.